Guten Morgen. The conference is Siki, huh? Hope I have it said right. Hope it isn't a bad word, but that's what I told to say when something is pretty good. So my Dutch is pretty much limited, so I'm going to switch to English and count on your contribution. I'm Vinicius. I work at Esri, as I was presented as a solution engineer in the United States. But I'm originally from Brazil, so I'm your neighbor, and I'm so honored to be here. I've always wanted to be in Suriname, as it is the land of one of my favorite players, Clarence Seedorf. So I admire a lot of the Surinamese players and the culture. Yeah. Yeah, not only Seedorf, right? Cliver, Davids, a lot of good players came from here. So I'm thrilled to be here, and it's an honor for me to be part of this conference. The subject of my presentation now is integrating GIS and BIM for smarter infrastructure. And I'm sure that a lot of you guys have to interact with engineering firms or engineering departments within your own organization. And I'm also sure that the most of you might be facing the same challenges when it comes to integrate data from infrastructure, data from engineering departments, and GIS, as everything happens at a place in the world. But we used to have a lot of departmental silos. So I have the engineering departments working on CAD and BIM generally, and I have the GIS people working with GIS. And what happens is that we have a lot of information loss in this process. There are some studies that show us that an engineer loses on average 40% of its time only checking information and making sure that he's working with the most up-to-date data. And generally, one company or one department cannot do it all when it comes to a public work or a construction. So we rely on contractors and we rely on third parties, or we rely on different departments to do the planning phase, and then to go to field and do data collection, and then work on analysis, design, construct, as built, and finally operate. And it happens to every single sector. If you are working with on the oil and gas segment, you are going to be building pipes, you're going to be building structures. If you are working with telecom, as the previous presentation, you've got to build networks, fibers, whatever. If you are working in the government, you've got to build bridges, infrastructure, so on and so forth. So it's a general problem. And it takes us to these numbers that are really scary. And this is a study that was carried out 3 years ago. It's a global study that shows that 30% of the materials are wasted, 30% of construction is rework, 40% of the buildings end up being underutilized, 40% of projects are over budget, and 90% of projects are late, and 40% of job site is unproductive due to this loss of information, bad communication, and we cannot keep on working like this anymore. Our world is under pressure. We can see all of the climate changes issues that have been challenging, and the construction industry, it's the second industry, or the second market, or second segment, as you call it, that contributes the most for the greenhouse emission effects. So it's one of the most contributors to the pollution, let's call it that way. And one of the ways that we see to really change the game is addressing it through the perspective of transforming the projects by integrating GIS and BIM. And it's pretty common for engineering firms to start working and building their projects out of scratch. So they just open AutoCAD and start drawing stuff without taking into consideration all of the environmental aspects, all of the social aspects, and all of the economic aspects. As every single construction has an impact, whether it's economical, social, or environmental. It happens. And before I go any further, I'd just like to ask you, how many of you are familiar with the BIM technology? I think that most of you might have heard of or might have used CAD, like AutoCAD. But how many of you know BIM or have heard about BIM? Like
building information models,
Yeah.
BIM.
Yeah, so 2 or 3 hands. Okay, good. So I'm going to take a step back and explain to you what BIM is about. If we take a look at the history of construction, we used to do, and I have some engineers here in the audience, and please correct me if I'm wrong. In the beginning, we used to do constructions with paper and pen. I was projecting something, I was just literally drawing it and then building it. After that, the greatest revolution that we had was the digital drawings. It happens in the 80s, in the 90s, with the AutoCAD, as you might have heard of it. So I've started drawing my projects on a computer, and that was the digital revolution that happened. But these digital drawings were just drawings. So there was no difference between a wall or a structure or whatever, because all of the elements were just drawings, or just lines or polylines, whatever you want to call it. It's different from GIS, that you have the attributes, you have rules, you have topology. If I'm drawing on CAD, I can draw a line and say that it is a wall, and I'm going to consider it as a wall, but I don't have the attributes that refers to this wall as a wall, like the number of bricks, for example, the thick, so on and so forth. So the BIM is this last revolution in the engineering market, and now all of the softwares are using this BIM methodology, and they are taking into consideration all of the attributes of the construction. So when I'm starting to draw on my 3D BIM software a wall, it's not going to be only a wall. I'm going to have all of the attributes. I'm going to have the painting that I'm using. I'm going to have the number of bricks, as I've mentioned, the thick, etc. And besides having all of these attributes, it helps me in 2 ways. I'm starting to build some information that is going to be stored, and it's going to be used throughout the generations. And it helps in maintenance and helps in security issues, as nowadays I only have paper or digital files that don't tell me the history behind that. So with these attributes, I can see literally when it was built, how, and when I should be performing some maintenance work with this kind of BIM. And besides that, it provides a easier environment so every discipline can come together. Because if you're building a vertical construction, like a building or an apartment or whatever, there are different engineering disciplines involved. So I have the electrical, I have the structure, I have the piping, etc. And before, everyone used to use their own software or their own sheet of information. Now they can all use a same environment. So this is also a parenthesis, this was a disclaimer and a brief introduction to the BIM methodology. And the BIM, it has the detailed information about built assets. I have the detail of the detail. I have the door, I have the information of the material that this door is made of, I have the handle, I have the information, whatever. It's the detail of the construction. But it doesn't exist without GIS, because BIM supplies detailed information about the built assets themselves, and GIS provides information about the assets in the context of the built and the natural environment. So they should coexist and not exist separately, as it is still happening. Because once connected, location can open a world of data, as it is the glue for everything that happens. It's the common thread for a construction, as through GIS, we can connect different sources of information, like vector, big data, imagery, tabular, terrain, CAD, BIM, 3D, real-time, so on and so forth. Given this introduction, let's see some examples, so you guys can better understand how it works. This is the famous AutoCAD. Oops, okay, thank you. Thanks for letting me know. Yeah, this is the famous AutoCAD. This is the digital drawing software that I had mentioned, and I can literally start drawing here. But now I am able to add geospatial information to this. We have an integration, we have an alliance with Autodesk, and I have this free plugin that you guys can download, and you can tell your peers, you can tell your colleagues who work with engineering that they can download and access your data through a service. So you don't have to convert files anymore, you don't have to download a shapefile, convert, open on CAD, vice versa. It's way easier now. So you have all of the context that you need in order to start a project. So I could add a map, like this world imagery map. It's going to be loaded in a matter of seconds. And then I can add all of the data regarding my project. So I can look for South American information, for example. And here I can consult my own organizational data, or I can look at the Living Atlas, which is the largest library of geospatial information in the world, and it's free. If you have access, if you have ArcGIS, you have access to it. So let's assume that I want to add this information right here. It's going to draw on the top of CAD. And again, it's GIS information on CAD. I don't have to be a GIS expert to access geospatial information in my own environment. So we are empowering engineers and CAD users and BIM users to use our information on their environment. So I've added this information right here, and let's assume that I want to do any changes or add any other feature. I can simply draw anything here, for example. And as soon as I finish it, I can synchronize and I can share it to ArcGIS. So the GIS analysts, they will see the changes that I have done almost in real time. It's just a matter of uploading or refreshing the project, and they will see it happening in real time on GIS, and vice versa. If I'm working on GIS, I do any changes here, they can refresh this project, and they will see all of the changes happening. So I'm connecting, I'm breaking down those historical silos. This is the engineering point of view, but if I'm working with ArcGIS, I could do the same. You can simply add a BIM or a CAD file without needing to convert, or even better, you can establish a BIM cloud connection if you happen to work with Autodesk solution. So I can name it, and it's going to access my own BIM and CAD library. Just let me add my credentials here. I'm going to allow them to access my information, and you can see here on the right, on my catalog, a BIM cloud connection already established. As I named it Paramaribo, it's going to be showing right here, and it's going to access all of the information that I have stored on the cloud. So I have all of these projects. Let's assume that I want to take a look at this Atlantic Water Facility. I can add the whole project or a separate file, a separate discipline. I can simply drag and drop, like this RVT file, which is it's a BIM model, and it's going to show up, it's going to pop up in the map in the same way that it did on AutoCAD. So no need of data conversion anymore. Uniting both worlds and take advantage of this strategic alliance that we have with Autodesk. So all of this is pretty useful, but it's more from the technical perspective, more from the technical point of view. But if you want to provide your managers, your director with another kind of possibilities, I have two final examples, and I'm going to try to rush as we are running out of time here. This is an example of ours. Our headquarters is located in a city close to LA, and we wanted to build a new building, and we used our own technology to see how to do a better design, a more sustainable design. So the first thing we did was putting in perspective all of the public services and utilities information that we have, so we could take a look and see where the electricity network was, the pipelines, the water, the sewers, so on and so forth. And if I click here, I can see all of the information regarding this electric line. The configuration, and if I click on the blue one, this is the distribution man, the material, so all engineering information, and I can add all other data that I want to, like the structural, so I can do a better planning, a better design on top of the engineering information. I can add the zoning, so I can see if I'm building it accordingly, and keep on doing my analysis. So again, uniting both worlds and not working separately anymore. And here, sky's limit. This is how the final construction looked like. And let me jump to this other example for the sake of time. But this is how it looked after it was constructed. This is a 3D model, a BIM model with all of the attributes, all of the details. And if I click on the roof, for example, I can see all of the attributes, the engineering attributes that I have. Again, accessing the data where it lives. Let me click here on the roof, and I can see the category, the family type, and all of this high level of details as I had mentioned. I can take a look in the interior. I can see the chairs. I can see everything that was projected here. And I can even look underground, and I can see the structure. It always gives me some kind of vertigo, but it's worth it. And I can also see the utilities. So the same utilities that I have seen from the top, I can see now from above with all of the attributes. And this is another example of integrating drone images with BIM and with project scheduling solutions. So here I know we are running out of time. I'm gonna keep rushing. I know you're desperately looking at me. Here I can see all of the phases of the project, so I can go back in time and see how the project looked like in 2020. I can go to 2019. And I can see the project evolving. And even better, I can put the BIM model on top of it, and then I can compare how the construction looked like in that given date and how it should be in that given date, so I can monitor delays, etc. And this is from our perspective, but from the public works perspective, we can create hubs so the population can access, and we can make it more transparent. So this is an example from Madrid. They were building a new bridge over here, so they decided to create this hub, the site where they could share this information, and the population could access and see the evolution of the construction in almost real time. So they have all of these cameras, and if I click on a camera here, I can see the traffic right now in this place in Madrid. You can see that it's literally today. And here I can see the other dates. This is a BIM model, an engineering model. If I turn on the October 7th, for example, I can see exactly where they were working on this given date. See? They were working on this red part, and I can even see the machines that were working on this given date. And finally, I promise this is my last example, because we've seen examples from United States, we've seen examples from Europe, but it's already happening in South America. And this is an example from Brazil. This is a state in Brazil in the border with Bolivia. And this is the Public Works Department, and they made available all of the infrastructure information, so I can see all of the public works that are happening in real time. I can check all of the trucks and where they are located at this very first moment, so I can keep track of them and of the assets, and the population can access and benefit from its transparency. See? I have the machines. Here I'll have all of the prices that they paid for acquiring these machines, and I will have the locations of them here on the bottom right. And I can also check it in real time I have the video monitoring of the constructions. It's open. You just can simply access and you see. December 6th, 1938, 1 hour less than here. And I keep on integrating BIM, GIS, project management, sensors, so the sky is the limit in this, in this case. And by integrating all of these products of information, I'm able to handle that historical problem that we have had of missing data, of not integrating data. And it's not only me saying, there's also studies that prove us the benefits of integrating the technology and how much time I would save in terms of design, construction, and even the budget that I would be saving. Thank you so much. You've been such an amazing audience. And if you want to access and if you want to see more resources about GIS and engineering, GIS and CAD and BIM, I'll share this link with you so you can access and check out the information that you have available. Thank you so much. It's been a pleasure.